In this video, I'm going to show you how to do regression analysis in Excel. I'm going to be using this Data Analysis ToolPak. If you don't have it, on Mac, you can just click on this Data tab and click on Analysis Tools, and then click the Analysis ToolPak. On PC, it's a little harder. It's under File, Options, Add-ins. I'll post instructions on how to get that on PC, but I can't show you because I'm on my Mac right now. All right, so when we're doing a regression analysis, we have some theory that we have some function that will help us predict y values, some output values based on some input x values. I'm going to move these over. And so basically what I just said is we said y is equal to a function of x. That's our hypothesis that we're working on here, is that y is a function of x. And we want to know what kind of model might be a good predictor of those y values. So I'm going to dive into this Data Analysis ToolPak and click Regression. And I'm going to select my y values. And I always like to incorporate that header row, which has the labels in it. And I'll tell you, this will become clear as I go through this. So I'm going to start with a linear model. You have the labels, residual plots, residuals. I don't need those. Residual plots and line fit plots. So I'm going to click OK. And this is going to output this new sheet. And the first thing I'm going to do is I'm going to move this sheet over, and I'm going to rename it to our linear model. So linear is y equals mx plus b, y equals mx plus b. And this model here has the intercept b and then this x coefficient 14. So this model is telling me y is equal to 14.57, x plus 1.35. That's the model that this is predicting. So we have a couple things we can look at here. This r squared value is a nice value. It tells me the confidence. It's kind of a goodness of fit measure. And so if this is closer to 1, that tells me that this model is a better fit to the data. But we also are curious not only how well does the model fit the data, but how confident are we in this model? And so a couple things I like to look at here are the p-values and these confidence intervals. For the intercept, the null hypothesis is that the intercept is 0. Here, if the p-value is less than 0.05, that means we reject the null hypothesis and we have some other hypothesis. So we can see that we fail to reject the null hypothesis that the intercept is 0. And I can believe that. This line looks like it might go through 0. And we have the confidence intervals of what that, this 95% confidence intervals of what that intercept might be. So it could be anywhere. This is outputting 1.35, but this model thinks it could be anywhere between -8 and almost 11 with 95% confidence. So there's pretty wide variation in what the x-intercept might be. The slope, it is confident on. So the slope, it says, is going to be equal to 14.57, and it's the p-value here is super small. And so this tells us that we are confident that that's a good predictor. And we can see this line shows that there is that this is a good model. The last thing I like to look at is this residual plot here. And if there's trends in the residual plot, that indicates that there might be something going on that our model's not picking up. And so if I look at here, the residuals up here are all above 0. Here they're below 0, and then here they're above 0 again. So we can see that there's a trend in the residuals, kind of this curved shaped trend, which suggests that all these values are above the line, all these middle values are below the line, and then all these higher values are above the line again. So this might not be the best model. So I'm going to go and I'm going to try to do another model to this data. I'd like these residuals to be normally distributed, randomly scattered around 0. So let's go back to my data, and I'm going to add an x to the squared term. And so I'm just going to go equals this to the squared. I'm going to drop that down. That's my x to the squared term. And now I can do a new model, and I can say regression. And now for my x data, the only thing I'm going to change in my x data, I'm going to highlight both these columns. Hit OK. All right, so let's look at what this is spitting out here. This is spitting out 3 coefficients. And so going backwards, starting with this one, we have y equals 1.33x squared minus 4.11x plus 61.566. So I'll write this down. Y equals 1.33 x squared minus 4.11 x plus 61.66. That's this model that this is showing me. I could see my r squared. I'll rename this to quadratic. So I can see this model has a better r squared. If I go over here to the linear model, our r squared was 97.97. Now it's 0.991. So better fit to the data. But the question we always want to ask is it a good model? And so let's look through these p-values. This first one for the intercept and this last one are both below 0.05. So that's good. This middle one is above 0.05. And so we have to question if this term is valid in our model. And I could always go back. I could do another type of quadratic function. So we don't have, this p-value fails to reject the null hypothesis. And I can go back and refit this. I could do another quadratic function with just the x squared term. With just that x squared term. So now this model is y is equal to 1.04 x to the squared plus 48. And all of these are significant, so this might be a good model. I encourage you, again, to always look at these residual plots here. And here, this does look more uniformly scattered around 0 without any trend in the data. So let me go to, I'll just rename this. That's my y equals x squared plus b model. I always like to go up to one higher level and just check to make sure that model is a good fit. So I'm going to do a cubic function here, x cubed, and I'm going to is equal to x to the cubed. I'm going to drop that down. And let's do our regression analysis on that. Okay, so I got all three coefficients here of x that I'd like to look at. And I'm going to click OK. This is a cubic function, so I'll rename it cubic. And I'll put this over here. All right, let's see what's going on here. So this cubic function, let me go back. This had a lower r squared than our quadratic, but higher or smaller p-values also. And so you kind of have to balance looking at a high r squared and low p-values. If I go to this cubic function, and let me look at this line fit plot here. This cubic function looks like it fits the data really well, and this r squared value is high, 0.992. However, if I look at these p-values, they're all bigger than 0.05. That suggests I maybe have overfit my model to the data, and this model is not going to be a confident predictor of new data. We always want to be cautious of overfitting our model. And so as a statistician or the analyst, I'm going to pick this model here, y equals 1.04 x squared plus 48. I actually can show you the equation that I used to make this data. I have this function here. I have some random x's, so this just gives me random x's, and this gives me the y value, which is the x squared plus some random noise plus 45. And so my function that I use to generate this data is y is equal to x squared plus 45 plus some random noise. That's my function that I use to generate this data. So we can see this is a pretty close estimate, right? It's 1.04 x squared plus 48, but it doesn't exactly match. And that just highlights the fact that all of these models that you're doing with your regression analysis, they're giving you the wrong. They can't give you the exact function that we're fitting, but it's useful. This is going to be useful to predicting the data, and we have confidence intervals of where these values fall. So that's my quick tutorial on doing regression analysis in Excel, and I hope you find that useful.